calculus 2, okay, several types of sequence, okay, and then from the sequence you can construct series, and there are many types of series, okay, such as geometric series, harmonic series, alternating series, and power series, and so on. There are many types, and each series has its own test, okay. So there are different types of tests, okay, to check whether the series diverge or converge, right? So each type of series has its own test, right? And some of the tests are root tests, ratio tests, okay, alternating series tests, and so on. All right. But in this class, we will focus on power series. Okay, we will focus only on power series, and then the test that involve that we will deal with is what is a ratio test, because ratio test is suitable for power series. Okay, before we go to power series, okay, as I mentioned earlier, okay, we can construct series from the sequence. Okay, first we need to have sequence first. Okay, what is sequence? Sequence is list of terms. Okay, list of terms, right? And we have two types of sequence, namely finite sequence, which is we have a finite elements or finite terms, and also infinite sequence. So we have infinitely many terms, go on forever, right? The two types of sequence, finite sequence and infinite sequence. Okay, and from this sequence, okay, you can construct series. Okay, from this sequence you can construct series. Okay, I think you still remember the terms n partial sum. Okay, n partial sum denoted by Sn. Okay, Sn for the finite sequence we call it Sn. Okay, for infinite sequence we call it S infinity, F sub infinity. Okay, from this sequence we can construct series. Okay, using n partial sum. Okay, so what is S1? S1 is the sum of the first term. Okay, so S1 is defined as the sum of the first term, A1. Okay, so what is S2? S2 is the sum of this of the first two terms, which is A1 plus A2. Okay, similarly, S3 is the sum of the first three terms, A1, A2, A3. Okay, and Sn, okay, is the sum of n terms, the first n terms, which is A1, A2, A3 up to An. We have n terms here, so we can represent this sum as the summations n from 1 up till n, okay, An. Okay, when An equal to 1, we have A1, okay, and then up till, okay, plus A2 up till An. Okay, this is another form to represent the sum of the first n terms, summations. So this is called n partial sum. Okay, and then from this partial sum, you can construct series. Okay, so A1, A2 is the term. Okay, the term. This is for the sequence. For series, okay, you construct S1, okay, S2, S3, and so on up to Sn. That is for finite series. Okay, from finite sequence, you can construct finite series. Okay, so similarly, for infinite sequence, you can construct infinite series. Okay, S1, S2, S3, Sn, and so on. Okay, so remember, series is what? Is this one is the sequence of n partial sum. Okay, series is the sequence of n partial sum. Whereas sequence is what? Is what? Is what? Is what? Is what I call it? Is this one is term. This one involves terms. Okay, this one involve terms, whereas in field series is involve n partial sum. Okay, that is the difference. This one n partial sum, when in sequence is a series of terms. Okay, terms. All right. So now we have this. Okay. So our task now to check whether this series diverge or converge. What you mean converge? Converge means it has some value, okay, some real value. Okay, the series is converge is it has some real values. Okay, for example, here it will goes to one some values, real values. Okay, and then diverge, that means we don't have this value. Okay, or the value is too huge. Okay, or they diverge, they have two different value, right? So that, okay, so that was your task in calculus 2, right? So let's review what is power series. Okay, actually C1 C1R C2R2 C2R3 cube and so on, this one is geometric series. Okay, a special kind of power series actually. Okay, because in power series all these are involved with what? Involved with dependent variable. Okay, so from your calculus 2 as well. Okay, the power series in x minus a, which is this one. Okay, you can write this out down as what? As c. Okay, summation n from 0 up till infinity cn x and x minus a power of n equal to, okay, when you replace n with 0, so you have c naught. Okay, c naught here. Okay, x minus a power of 0. X minus a power of 0 is equal to 1. The 1 times c naught becomes c naught. Okay, and then plus, now you increase n by 1, so now become n equal to 1. So we have c1 here, x minus a power of 1. Okay, and then increase n by 2, then we have c2 x minus a power of 2 plus blah blah blah. Okay, this is infinite series, infinite power series. Okay, now we're talking about a special types of series called power series. Okay, all right. As I mentioned earlier, this is power series, but in this case, we call it geometric series. So geometric series is a special kinds of power series. Okay, where this one is doesn't involve, okay, it doesn't involve dependent variable, but for power series is involved. This one is must be dependent variable. Okay, now to check, okay, to check whether the series converge or diverge, this process is okay. This series is also called power series centered at A. Okay, x minus A. So the centered is at A. Okay, you can relate this to Thales expansion. Okay, Thales expansion. Okay, when you expand a function, okay, using Thales series about x equal to a, or the centered is a. Okay, you can recall that. You can recall your Thales expansion or Thales series in your calculus 2, but I will touch that later. Right. So convergent. So we want to test whether this series converge. Okay, and converge to what, to what value, right? So this series, okay, this series, right? And then this one have limited terms. Okay, this Sn and then S infinity have infinitely many terms. Although have infinitely many terms, we want to test whether it converge or diverge to what value. Okay, okay. So this one for Sn, it doesn't matter. I mean, we can find the value. Okay, there's no question about it. We just add the value up to n terms. Okay, so we will get this value. Okay, there's no question about this. But the problem is when it's involved with infinite series. Okay, in this case, when it involves with n partial sum for when n is approaching infinity. Right. So this one, the terms is infinitely many. Okay, it won't stop. Okay, you won't get the value. There is no ending points. Okay, so there is any points. You cannot get that value. You cannot find this value, right? But are there any other ways to predict, okay, whether this series diverge or converge? Okay, all right. So since it's impossible to add all these terms to find the value because it's never-ending process that I mentioned earlier, one of the strategy is what? To find Sn. Okay, to find n partial sum, and then we take the limit as this n goes to infinity. Okay, so we find n partial sum, and then okay, we take the limit as n goes to infinity. So we use the limit. Okay, as n approaching infinity, this as n approaching as infinity. Okay, that is one of the usage of limit. You don't have to calculate everything. We just take the limit. Okay, and we know that S and X, which is n partial sums, is equal to this. Okay, and we take the limit of this n partial sum. If the limit exists, then the series converge. If not, then the series diverge. Remember, we are talking about infinite series. Okay, this finite series we have no issue. We can calculate. But infinite series we cannot calculate. We take the limit. Okay. All right. Any question before I proceed? This is the concept. Okay, this is the basic concept that you should understand. Right. Is there any question before I proceed? No question. All right. Okay. You also learned in calculus 2 how to find interval of convergence and also radius of convergence. Okay, interval of convergence and radius of convergence. Why do we need to find interval of convergence and also radius of convergence? I will explain later. Okay. So for interval convergence, we need to find the interval of convergence in order to find the all real numbers that make this series converge. Okay, we need to find interval of convergence in order to determine the all real numbers that make this series converge. Okay, that is the use of interval of convergence. Okay, the same goes for radius of convergence. Actually, interval of convergence and radius of convergence, they are interrelated. Okay, they are interrelated. Okay, the same thing here. Okay, what is radius of convergence? Okay, if R is the radius of convergence, okay, the power series converge for absolute value of x minus a less than R, okay, and diverge for absolute value of x minus a greater than R. Okay, it's only converge when x minus a, remember x, a is what? Point of expansions or center of expansions, okay, less than this R, this rate of convergence. Okay, and then diverge when x minus x value greater than R. Okay, example 1. Okay, for what value of x is the series? Okay, n from 1 until infinity, n factorial x power of n converges. Okay, I mean we're dealing with power series, infinite power series. Okay, in order to determine, okay, this infinite power series converge or diverge, okay, you need to use ratio test. Okay, we need to use ratio test. So what is ratio test? Okay, first of all, you need to identify what is AN. What is the N terms? Okay, so what's inside in this summation is the AN. So AN, the N terms is equal to N factorial times X power of N. That is AN. So AN plus 1, the next term will be AN plus 1. So each time you see N, okay, you replace N with N plus 1. So N plus 1 will be N plus 1 factorial X power of N plus 1. Okay, every time you encounter with N, you replace N with N plus 1 to get AN plus 1 terms. Okay, now to use ratio test, we need to take the ratio AN plus 1 over AN. Okay, and then take the absolute value of AN plus 1 divided by AN. Okay, so you replace AN plus 1 with N plus 1, the whole thing factorial. Okay, Xn plus X power of N plus 1 over AN will be N factorial times X power of N. And then we have to simplify this. Okay, simplify these expressions. Okay, so N plus 1 factorial can be written as N plus 1 times N factorial. Okay, so N plus 1 factorial is equal to N plus 1 times N factorial. Okay, so dia macam ni lah, dia macam ni. Kalau macam ni, kalau macam 3 factorial. What is 3 factorial? Okay, 3 factorial is equal to what? 3 okay, times 2, okay, 3 times 2, okay, times 1. Okay, so equal to, okay, 3, okay, 2 times 1 is equal to what? Equal to 2 factorial. Okay, so 3 factorial is 3 times 2 times 1, but 2 times 1 is 2 factorial. So equal to, okay, 3 times 2 factorial. The same thing here. Okay, N plus 1 factorial equal to N plus 1. Okay, that means N plus 1. Let me call this. Okay, times N. Okay, times N. Times N. Okay, times N minus 1. Okay, times up till 2. I could use only 3. Okay, until up to, okay, times 1. Then you stop. Okay, but N plus N times N minus 1 up till times 2 times 1, in this one is equal to, this one is equal to N factorial. Okay, equal to N factorial, and that's why you can replace N plus 1 factorial as N plus 1 times N factorial. Okay, okay, and then X power of N, you can rewrite this as X power of N, okay, plus X times X. So X power of N plus 1, you can rewrite this as X power of N times X. Okay, why we do this? Because we want to simplify. Okay, so now, okay, N factorial and N factorial kita cancel, habis. Okay, and x power of n, kita cancel. So what's left is n plus 1, okay, times x. Okay, so the ratio of n plus 1 over n is equal, absolute value is equal to absolute value of n plus 1 times x. Okay, and then for ratio test, we need to take the limit, okay, as n goes to infinity of this ratio. Okay, you have this ratio, and you have to take the limit as n goes to infinity. Okay, so limit n goes to infinity, the ratio of an plus 1 over an is equal to, we know that this term is an plus 1 over n, so the value is the same as the value of n plus 1 x times x. Okay, so now only this term, okay, only n will change. Okay, x remain unchanged. Is it now we treat x as constant? We can take x out. Okay, so we can take absolute value x out. Okay, this is the properties of limit. Take x out, so value x. Okay, limit n goes to infinity. Okay, n plus 1. Okay, if you use the ratio test, okay, the series converge if and only if and only if this limit is less than 1. Okay, that is ratio test. Okay, if the limit is less than 1, then the series converge. If the limit is greater than 1, then the series diverge. If the series equal to 1, the test fail. You cannot use ratio test to determine whether these series converge or diverge. You got to use other tests, okay, such as root test and so on. Okay. Okay. So the series converge is this limit is less than 1, meaning that, okay, you know that as n goes to infinity, this term will be very huge numbers. Okay, so this one will goes to 1 if and only if the x value is equal to 0. Okay, if the x value is equal to something, time the huge number will be greater than 1. Okay, so to guarantee that this limit less than 1, the value of x must be equal to 0, because 0 times this huge number will guarantee that is less than 1, which is equal to 0. Okay, so in this case, okay, only when x equal to 0, this power series will converge. Other than that, it will diverge. Okay, so meaning that it only converge when at one value only. Only one value, which is x equal to 0. So what is the convergence of interval? X equal to 0. Okay, only one value. Okay, and then it cannot be less than 0. It cannot be greater than 0. That means when you plot the line numbers, okay, the point cannot go to the right or to the left. Okay, in this case, the radius is also equal to 0 because only one point. Only one point, there is no radius. We cannot move to the right, we cannot move to the left. That means now r equal to 0. Okay, so what is the convergence of interval? X equal to 0. What is the radius of convergence? R equal to 0. Is there any questions? Okay, we go to second example. Okay, for what values of x is the series, okay, n over 3n plus 1 x of n converge? Okay, the infinite series. Okay, converge. Again, we use ratio test. Okay, an equal to n over 3n plus 1 x power of n. So an plus 1 will be n plus 1 over 3n plus 2. Okay, because you replace n with n plus 1, you have n plus 1 plus 1, which is n plus 2. Okay, x power of n plus 1. So you replace this n with n plus 1. All right, and then you take the ratio test. The ratio first. So an plus 1 over an is the value. So you replace this an plus 1 with n plus 1 over 3 n plus 1 times x power of n plus 1, okay, over, okay, n over 3 n plus 1, okay, x power of n. You can rearrange this, okay, as n plus 1, 3 n plus 1, okay, n plus 1, okay, this, okay, now, okay, this will, the reciprocal, this will be on the top, okay, and this will be in the bottom, okay, 3n plus 2, okay, then x power of n, right? Okay, okay, if you don't, if you cannot see this, this is equal to, I will copy this, copy, okay, it will be like this. Okay, this will be this one. Okay, and then times, so it's times, okay, time this. So sorry, divide this. Divide by this. Okay, and then if you want to times, then you want to take the times, then you got to reverse this one. So this one will be up, this one will be down. Okay, so it will be okay, home cut be here, paste, it will be here, that will be here, a paste, it will be like this. Okay, okay, and that's how you get this term. Okay, this time this will get this term. Okay, the denominator, and then all this time this we will get this. Okay, okay, all right, and then we need to simplify. Okay, n plus 1 times 3 power of n plus 1, x n plus 1 can be written as 3 power of n times 3. Okay, and then x n plus 1 can be written as x power of n times x power of x, sorry, x times x, and then n times 3n plus 2 can be written as 3 power of n times 3 square, so x power of n, so 3 power of n and 3 power of n cancel, okay, and then 3 and 3 power 3 square, we have 3 there, okay, so 3 over 3 square, we have 3, and then we have n, xn cancel, okay, so we can simplify this as n times n plus 1 times x over 3n, okay, over 3n. Okay, and then we need to take the limit as n goes to infinity of these terms. Okay, an plus 1 over an is the value. Okay, replace this with this term. Okay, so now, okay, now only n will change. Okay, so x and 3 remain unchanged. So we can take x over 3 out. Okay, because this is the same as what? It's the same as, you can express like this. Okay, you can express this like this. Okay, I can take this. Okay, got here, I put here. Okay, times here. Okay, x over 3. Take these 3 out. Okay, the same as this. Okay, and then you can take x over 3 so value out. So x over 3. Okay, you have the limit n goes to infinity. The remaining term is n plus 1 over n absolute value. Okay. Okay, now what is this limit? N plus 1 over n. You have, when you replace n with infinity, the top part will be infinity over infinity. Because infinity plus 1 again is a huge number. Okay, so we have infinity over infinity. We can use L'Hopital rule. Okay, and then this will be what? Equal to 1. Okay, n plus 1 over n. Okay, and when n goes to infinity, it will goes to 1. It will approach 1. So 1 times x over 3, okay, is equal to what? Is equal to x over 3 absolute value. Okay. Is there any questions? Is there any question? Do you know how to get this limit is equal to 1? Siapa yang ada problems? The limit, this limit equal to 1. Okay, you use L'Hopital rule. Semua faham ke?
Sir, kalau untuk dapatkan, kan tukarkan limit tu kan, maksudnya macam kena dapatkan term tu dulu kan, an plus 1 ni dulu baru boleh
Yes.
limit.
Yes, ambil sini dulu. Sebab kenapa kita keluarkan yang ini? Sebab dia n yang berubah. Okay, x dan 3 remain unchanged. So we use the properties of limit, kita boleh keluarkan yang tak berubah tu. So we keluarkan x over 3. Okay, and when n plus 1 over n, then when n goes to infinity, n plus 1 will goes to infinity. And then this term also goes to infinity. And you have infinity over infinity forms. Okay, and that's why you need to use L'Hopital rule. Ingat lagi tak apa L'Hopital rule? Ingat tak? Siapa yang tak ingat? Siapa yang perlu saya terangkan lagi sekali? Semua faham ni L'Hopital rule? Semua faham ke? Semua diam tu faham lah ya. So L'Hopital rule. So we know that this one x over 3, and this limit must be less than 1 for this series to be what? Convergent. It must be less than 1. Okay, so this limit must be less than 1, but this limit is equal to x over 3. Absolute value must be less than 1. So you replace this term limit with x over 3, this term, right? Less than 1. Okay, or okay, that means that x must be between minus 3 and 3. Okay, x must be between minus 3 and 3 for this value to be less than 1. Okay, so that means, okay, so x equal to 0 centered, dia kosong sini, because x equal to x minus 0. Okay, x equal to x minus 0, or yang ni you boleh tulis sebagai x minus 0 less than 3. They are the same. Okay, that means here imply that x between minus 3, x and also 3. All right, so the center is x equal to 0. Okay, and it can goes to minus infinity, minus 3 and 3. Okay, so the interval of convergence is x between minus 3 and 3. The radius is 3 because it can move 3 units to the right and 3 units to the left. Okay, and that's why radius of convergence is 3. Okay, so the whole thing is interval of convergence. Okay, and it can move 3 units to the right and 3 units to the left. That means 3 units. I mean radius of convergence is 3. Any questions? That means only x between minus 3 and 3 will make this series converge. Okay, when x equal to 4, 4 no longer in this radius, the series will diverge. Okay, only when x between minus 3 and 3, the series will converge. When we will get the value. Okay, outside this radius of convergence, the limit, the series will diverge. Okay. Okay, example 3. Okay. We want to find the radius of convergence, the value of x that make this series converge. The same thing as before. So an equal to x minus 3 power of n over n. So an plus 1 equal to x minus 3n plus 1 over n plus 1. Take the ratio test. An plus 1 over an equal to replace an with x minus 3 power of n plus 1 over n plus 1 divided by an divided by x minus 3 power of n over n. Okay, so we can rewrite this as x minus 3 n plus 1 times n. This one we reverse this time n over n plus 1 times x minus 3 power of n. Okay, and then we can write x minus 3 n plus 1 as x minus 3 power of n times x minus 3 times n. Okay, so yang ini adalah this one, this term. Okay, and then over x minus 3 power of n times n plus 1. So you can cancel x minus 3 power of n and x minus 3 power of n. Okay, the rest remain unchanged. Now you have simplified this. You have n times x minus 3 over n plus 1. Okay, and take the limits. Okay, take of these limits, right? And then you know that x minus 3 remain unchanged. You take that out to have the value of x minus 3. And then you have to take the limit of n over n plus 1. Again, this one you have to use L'Hopital rule, and the limit is equal to 1. So you have x minus 3 absolute value. Okay, and this value must be less than 1 in order for that series to be convergent. Okay, that means this series must be less than 1. Okay, meaning that from here x must be between 2 and 4. Okay, so x minus 3 less than 1, meaning that x between 2 and 4. Okay, you use the definition of absolute value. Okay, so that means x minus, okay, here that means x minus 3. Okay, macam ni lah. Okay, here explain here like this. Okay, from here mean that x minus 3. Okay, I put here. Okay, x minus 3 on everything. Copy. That means x minus 3 here. Oh, I take this one. Copy, put here. Okay, paste, that means x minus 3. Okay, that means must be less than minus 1 and then greater than less than 1. Okay. I put O here. O here. Okay, when you use the definition of the value, okay, absolute x minus 3 less than 1, meaning that x minus 3 must be greater than minus 1, less than 1. Okay, that is from the definition of absolute value. Okay, when you simplify this, okay, you bring 3 to the when minus 3 cross the inequality, it becomes plus. That's why we have here minus 1 plus 3 will be 2. Okay, and then 1 plus 3 will be 4. So that means x between 2 and 4. Okay, from here we will get this. To get this, you use the definition of absolute value. Then from here you will get x from between 2 and 4. And then you know that now x minus 3, meaning that the center of expansion is 3. Remember, before this we have x minus a. The center of expansion is x equal to a. So x minus 3, now the center is x equal to 3 here. Okay, so and then the interval of convergence is between 2 and 4. Okay, this is the center x equal to 3. I mean, from the center we move 1 unit to the right, 1 unit to the left. So in this case, r is equal to 1. Okay, that means here r is equal to 1. Okay, and the interval of convergence is x between 2 and 4. Okay, 2 and 4. So any questions? Any questions? Okay. If there is no questions, okay, now there are some terms that you need to familiarize with. We call it analytic at a point. Okay, analytic at a point. Okay, so we can relate this. Okay, now we're talking about a power series defines a function. Okay, now this is power series. Okay, we define this power series as y. Okay, y now can be written as power series, or we can represent y in terms of Taylor series. Okay, because power series is what? Is a special kind of Taylor series. Okay, now if the function y is defined as this power series, then y prime, the derivative of y is y primes, so dy dx. Okay, so we need to find the derivative of this. That means we differentiate Cn x of n, it will be what? N, you bring n in front, Cn remain unchanged because Cn is constant. Okay, and the n is x is independent variable, so x will reduce the power by 1. Okay, so when y equal to summation n from 0 up to infinity Cn x of n, y prime will be n Cn xn minus 1. Okay, and then from n from 0 up to infinity. But then when n is equal to 0, this term will be 0. Okay, when n is equal to 0, this term will go to 0. Okay, will be 0. But when n equal to 1, this will be C1 okay, xn minus 1. That means this will be C1 when n equal to 1. So now instead of starting from n equal to 0, we can start n from 1. Why? Because when n is equal to 0, this term will be gone. There is no value when n equal to 0. Okay, so we can start n from 1. Okay, similarly, okay, y double prime will be what? We differentiate y prime, we have y double prime. So this will be n times n minus 1. Okay, we bring n minus 1 in front, and then c n minus, now n minus 1 will be n minus 2. Okay, okay, similarly here, when n equal to 1, when n equal to 0, this term will be 0. Or when n is equal to 1 here, this term will be 0. 0 times anything will be 0. So the first two terms will equal to 0, no value. And that's why we can start here with n equal to 2. Okay, we can start here n equal to 2 because the first two terms is 0. So no need to consider. Okay, the same thing here. The first term is 0. That's why we start n with 1. Okay. Okay, identity properties. If all Cn is equal to 0, that means we have y equal to 0. If all Cn is equal to 0, then we have the series is equal to 0. Okay, and a function f, which can be written as power series. A function f is analytic. The keyword is analytic. Is a point at a point A. Okay, so f is analytic at a point A. That means x equal to A. If it can be represented, by a power series in x minus A. So that means that we can expand this point. Okay, A will be the point of expansion or the center. Okay, it can be written in power series in A minus A with a positive radius of convergence. Okay, that means the radius, there must be positive radius of convergence. Okay, so for example here, okay, f of x equal to e power of x. Okay, f of x equal to e power of x. You know that, okay, if you use Taylor series, okay, e power of x can be written as 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so on. Okay, and then you know that here, okay, here a will be 0 because x equal to x minus 0. So f here is what? Analytic at x equal to 0. Because the center of this Taylor's expansion at x equal to 0. The same thing here. Okay, f of x equal to, f of x equal to sine of x. It should be okay, and then we can write this as x over x cubed over 3 factorial and so on. Okay, the same thing for cos x. Okay, cos x we can write cos x as, okay, as series. Okay, and then, okay, now also here the point expression is x equal to, and then you know from calculus 2 that if the center is x equal to 0, this is a special kinds of Taylor series. We call it Maclaurin series. Okay, Maclaurin series is Taylor series when the point of expansion is when x equal to 0. So this is Maclaurin series X series. Okay, and then this is your Taylor series. Okay, how to get this? Okay, from here. Okay, so now what is fx naught? In this case, x equal to 0. So f of 0, okay, f of x equal to this. Okay, what is f of 0? Okay, f of 0 equal to e of 0. Okay, if of 0 is equal to 1, and that's why you have 1 there. Okay, using this, and then x minus 0, that means x. What is f prime 0? Okay, when fx equal to ex, f prime x equal to ex. Okay, and when you replace x with 0, so you have equal, same to equal to what? Equal to 1 here. And that's why you have, okay, x, okay, minus, okay, x times 1, which is x. Okay, this one over 1 factorial, which is 1 factorial. So you replace f double primes, that means ex with 0, we have 1. 1 times x minus 0, you have x squared over 2 factorial. And that's why you have this term here. Okay, you get this by using Taylor's series. Okay, as I mentioned earlier, when x equal to 0, the series is known as Maclaurin series. Okay, that's from this example. That's why we have here. Okay, we use Maclaurin series when x not equal to 0. So for f of x, so we have here, we have e0, okay, and that's why, okay, for e of x, we have this. Okay, you replace x with 0. So from here you get 1. From here you get x, or x over 1 factorial. From here you get x squared over 2 factorial. From here you get x cubed over 3 factorial. From here we get x4 over 4 factorial. So we get that one. Okay, that is series. Okay, all right. One last thing before I end our today's lecture. Okay, is about shifting the index. How we want to shift the index of summations. Okay. All right. First, verify that this summation on your left is indeed equal to the summation on your right. Okay, this is the same of this. But you notice that the index are not the same. Okay, n is equal to 1, here n is equal to 0. Okay, but here is n power minus 1, here is n. Okay, but they are indeed the same. Okay, to check whether they are the same or not, first you need to expand all terms in each summation. Okay, so we expand each term on your left. Okay, so we want to expand this term on your left. Okay, when x equal to 1, so this will be a1, x plus 1. So 1 minus 1 is 0. So x plus 1 power of 0 is equal to 1. That means 1 times a1 equal to a1. So we have this one. So when n equal to 1, we have a1. Okay, plus when n equal to 2, we have a2, x plus 1, 2 minus 1. Okay, 2 minus 1 is equal to 1. That means x plus 1 power of 1. So we have x plus 1, a2. And we can get a3 and so on. Okay, so when you expand the summation on your left hand side, you will get this term. Okay, you will get all the terms that make up this summation. Okay, expand all summation on the right hand side. The same thing here. When you replace n with 0 here, you have a 0 plus 1. So you have a1 Okay, x plus 1 power of 0, you have, which is 1. Okay, 1 times a1 equal to a1. Okay, when n equal to 1, you have a1 plus 1, you have a2. I mean, x plus 1 power of 1, power of 1, you have a plus 1 power of 1 is x plus 1 times a2. You got the second terms. Okay, the third term is equal. You can compare all these terms and this term, they are the same. And therefore, we can conclude that, okay, these two summations are the same. Okay, even though here the index are different and the power are different, but they are representing the same terms. Okay, so we conclude that one. Okay, or okay, this we compare. We list one by one. Okay, we list one by one. Okay, but the question is there any shortcut? If there any shortcut to check whether these two terms are these two summation are the same? The answer is yes. There is shortcut. Okay, let me try to do this. Right. We want to check whether those two are the same. Okay, now, okay, we refer to the right hand terms. Okay, so a n x plus 1 n minus 1. And now you notice that on your right hand side, the power is equal to n, whereas on the left hand side equal to n minus 1. Okay, and then to make this equal to power of n, you got to replace this n with n minus 1. So every time you see n, you replace n with n plus 1, so that n plus 1 minus 1 will equal to n. Okay, so every time you see n, you replace with n plus 1. So n from 1, n equal to 1, that means n plus 1 equal to 1. an become an plus 1. So x plus 1 remain unchanged. So n minus 1 replace with n plus 1 minus 1. Okay, I'll write that in red so that it's easier for you to see. Okay, now n plus 1 equal to 1. Bring 1 to the left hand side, become minus 1. So it means n equal to 1 minus 1, n equal to 0. Okay, you bring this n to the right hand side, become minus 1. So this term will be 1 minus 1 becomes 0. All right, and then x plus 1, and then n plus 1 minus 1 equal to n. Okay, and then you compare this. So this, from this, we can get this. Okay, you compare this term and this term, they are the same. Okay, they are the same. So we can conclude that those two given n partial sum or series, those two infinite series are the same. Okay, you have two approaches. One we can expand. Okay, but this is quite long, right? And the other approach, you can change the index. Okay, you change the index. Okay, you notice that the power from here, n minus 1, you want to become n. So every time you see n, you replace n with n plus 1, and then you simplify. And if they are the same, then those two given infinite series are equal. If they're not the same, then they are not equal. In this case, they are the same. So they are equal. Okay. So I think that's all for today. Okay, until remember this coming Thursday, there is no class.